Okay, so today let's take a look at a question on vectors in 3D coordinate geometry. So in this question, we are given the equation of the plane P and the equation of the line L. Part A of the question says, find the value of A such that the line L and P do not meet in the unit point. So we are supposed to find this unknown. So let's draw a diagram to illustrate this situation. So we have the plane P, say we have a normal N, and in order for the line not to intersect the plane, the only way we can draw it is such that the line must be parallel to the plane, which looks something like this. So the first thing we can do is to find out the normal of the plane, which we can obtain by simply crossing the two directions given to us, which is this and this. So we get 1 minus 5, 1, cross with minus 3a, 1. So after crossing, we should be able to get minus 5 minus a, minus 4, and a minus 15. And also, we got to convert the Cartesian equation of the line into the vector equation of the line form. We can just simply let this be alpha, let this be alpha, and try to express x in terms of alpha. So from the first equation here, we can get x equal to 4 plus 3 alpha. Second equation here, we will get y equal to 1 plus 5 alpha. Z will just simply be 0. So therefore, the vector equation of the line is given by 4, 1, 0 plus alpha 3, 5, 0. Alpha is an element of all real. Alright, then we can observe from the diagram that the normal of the plane will be actually perpendicular to the direction. That means to say, this will be perpendicular to this. And we know that if two vectors are perpendicular to each other, when we dot them together, you should be able to get 0. So we'll be using 3, 5, 0, dot with minus 5 minus a minus 4, a minus 15 will be equal to 0. So dotting out, I get minus 15 minus 3a minus 20 equal to 0. So therefore, solving for a, I will get a equal to minus 35 over 3. Right, so now let's look at part B of the question. And in this question, it says that A now is given to be 7. Find the coordinates of the point at which the line L and P intersect. So now we have a bit of different situation here. So part B, A given by 7. So now we have the plane here, and the line will actually intersect at this particular point here. So maybe I can call this point as point B, and maybe we can just find out what is the normal vector first by subbing in A equal to 7. So when A equal to 7, I will get minus 12 minus 4 minus 8. Factorizing out minus 4, I'll get 3, 1, 2. So the normal of the plane will just be 3, 1, 2 will be in the simplified form. So therefore, using r dot n equal to a dot n. So r dot 3, 1, 2 equal to a is just simply any point on the plane, which is given by minus 3, 0, 4. Dot with the normal vector, which is 3, 1, 2. So after dotting, I will be able to get minus 9, minus 1. Right, so now perhaps I can call this equation 1 and my equation of the line to be equation 2. So to find the point intersection, basically I can just substitute the entire expression of the line into the r here to find the point intersection. So maybe I can just write it here. So point of intersection, I will just substitute this entire line into the r. So I will get 4 plus 3 alpha, 1 plus 5 alpha, 0, dot with 3, 1, 2 equal to minus 1. So dotting out, I get 12 plus 9 alpha plus 1 plus 5 alpha equal to minus 1. So therefore, solving alpha equal to minus 1. So after we get alpha equal to minus 1, the last step I need to do is to simply sub alpha equal to minus 1 back into this. So therefore, OB, which is my point intersection, will just be equal to 410 minus 350, which will give me 1 minus 40. Okay, so let's take a look at the last part of the question. The last part of the question says that find the Cartesian equation of the line L prime, the reflection of L in P. I rewritten the scalar dot product form of the plane here and the vector equation of the line here. So let's draw a diagram to illustrate the situation again. So we have a plane P. So let's have an equation of the line L. And it will intersect at point B, which we have found earlier on, which is 1 minus 40. And we are supposed to find the reflection of line L about this plane. So I will get something like this. So this is L prime. So we know to find the equation of a line, we need two things. The first thing is a point passing through the line, and the other one is a direction. So from this diagram, we can see we have a point, but we do not have a direction. But what I can see, maybe I can find out a point here. So after finding a point here, perhaps I can find the direction of this line. So what I can do, I can consider a point here, and maybe I can find the full or perpendicular here. After finding the full perpendicular, I should be able to find the reflected point. So this is what I'm going to do. So first, I will consider a point lying on L. I think the most convenient point to choose is here, which is 410. Maybe I can just call it A. And the full perpendicular, I call it F. And this point, maybe I call it A prime. Right, so what I'm going to do, right, I will try to find the equation of a line that passes through point A and parallel to the normal. And after that, I'm going to use this line to intersect the plane. Right? Let's do it this way. So L will just be AF R passing through 410. Maybe I can call it beta. Normal of the plane, which is parallel to this line, which is 312. Beta is all real. So I'm going to use this equation of the line to intersect the plane. So I'm going to put this entire expression into the equation of the plane. So I will get 4 plus 3 beta, 1 plus beta, 2 beta, dot with 312 equal to minus 1. Let's work it out. I'll get 12 plus 9 beta plus 1 plus beta plus 4 beta equal to minus 1. So solving for beta, I will be able to get minus 1. And to find OF, I will just simply sub beta equal to minus 1 back into here. I'll get 410 minus 312, which is equal to 10 minus 2. Right? So I have my A prime. And to find, I have my OF. So to find A prime, right, I just make use of the ratio theorem. So OF will just be 1 times of OA plus 1 times of OA prime over 1 plus 1. So doing a bit of arrangement, so I got OA prime will just be equal to twice OF minus OA. So I'll just sub OF with 10 minus 2. OA will just be equal to 410. And solving it, I will get able to get my OA prime to be minus 2, minus 1, minus 4. Therefore, BA prime, which is the direction of this line, will just be equal to OA prime minus OB, which is minus 2, minus 1, minus 4, minus OB, 1, minus 4, 0. So I get minus 3, 3, minus 4. Right, so therefore my equation of the line will just be equal to passing through point B, which is 1 minus 4, 0. Sorry, I just squeeze a bit, plus gamma of minus 3, 3, minus 4. Right? And since the question requires us to find the Cartesian equation, so I will just convert this into the Cartesian equation, which it will give me a final result of minus 1 minus x over 3 equal to y plus 4 over 3 equal to minus z over